You have to make up your mind, kids here. Hello. Got a whiny guy here. Meow. Hello there. Just let me know if you have any questions. Hey, Esther. Hey, Kitsy. Just wandering around the country. I'll just wait until it seems like maybe a few more people come. Oh, thank you. He's really nice. He's napping against the computer screen right now. He's on the other side of the screen. His head's like right here. Hey. Maybe you can hear him purr. So yeah, just first and foremost, hope all of you guys are doing pretty well. Hope you and your families and loved ones are doing well. But yeah, I decided to push the quiz back to Friday. We were gonna do it tomorrow, but I realized we just had one yesterday, so figured I'd give you guys a little more time just to digest some stuff. So we'll have the quiz on Friday instead. Yeah, so let me know if you want me to go over anything or if you have any questions at all. Yeah, if you hear a rhythmic pulse, that's the cat purring. It's like right by the computer. You couldn't find and do the quiz yesterday? Was that what you're talking about? The quiz? Yeah, it's on Canvas. It's called the Kinetic Molecular Theory Dalton's Law Graham's Law quiz. So it should be on Canvas. Did you have trouble downloading it or anything, or you just couldn't find it on there? Let me see if I can. Yeah, if I go to the student view, it's under quizzes. Yeah, so I'm on student view right now on this other computer, and yeah, it says upcoming assignments. I mean, if you just go to assignments, though, you can probably find it. So I'm trying to do this backwards. I should go this way. Let's go down. Okay, there we go. So yeah, under assignments, yeah, it should be. Let me just scroll to it. It's on upcoming assignments. I guess that's how it's grouped on here. I'll just group it by type instead. Show by type. Yeah, so it's under quizzes and tests. It's the one that says kinetic molecular theory, Graham's law, and Dalton's law. Yeah, so it should be on there. If anything, just let me know if you're still having trouble. I can't remember who you are, by the way. I'm not sure who you are. Yeah, Graham's law example. So the velocity of gas A is equal to velocity over velocity of gas B is equal to the square root of the mass of gas B over the mass of gas A. So something kind of like this. This is Graham's law's equation, but just keep in mind velocity of gas A is on top, whereas the molar mass of gas A is going to be on the denominator underneath this radical. So The way that I think about it is we know that lighter gases are going to be faster. So let's just think of any two gases. I'm just going to think of two random gases right now. CO2 versus water vapor, H2O. So CO2, we know, has a molar mass of 44 grams per mole. H2O is 18 grams per mole, right? So molar mass of CO2, molar mass of H2O. So H2O is lighter, so we expect it should be quicker, right? It should be faster. So I say, since you're trying to see how much, whenever we look at these Graham's law equations, we're usually trying to calculate by what factor is the lighter gas faster than the heavier gas. Excuse me. So we're trying to figure out how much faster water is than CO2 with this random example I just put down. So it'd be good to put the lighter gas as VA. That way, if you're solving for VA, you can just multiply both sides by VB, and then you'll get your factor there. You could do it the other way too. It really doesn't matter as long as you're consistent. Some of you guys almost had it right, except molar mass of B was up here and velocity of B was up here. So it looked like you guys had them on like this, like parallel to each other, but they should be diagonal. So we know water is lighter than CO2, so it's going to be faster. So I'm just going to call this one the CO2. I'll say is mass B then, because it's the heavier one, and water I'll say is mass A. All right, so I'll just say velocity of water on top, velocity of CO2 on the bottom, and the molar mass of water is down here, 18. Molar mass of CO2 is up there, 44. All right, so it's kind of like that. So we know H2O is faster because it's lighter. CO2 is slower because it's heavier. So these problems are pretty much always going to ask you by what factor is the lighter gas faster than the heavier gas. So I just always make the lighter gas VA, the velocity of A. So H2O is lighter, so I put it on top. But that means its molar mass has to go on the bottom down here. Right? Sometimes people I think saw this and they put the lighter one up here, but then they put the molar mass of the lighter gas up here as well. So just try to keep that in mind. So in this case, I don't have my calculator on me, but you would just basically solve for whatever this value is, get V of H2O by itself. And so, maybe you guys are confused by the fact that there's still like another variable here. So you'd get something like this, solving for the velocity of H2O, right? So you're solving for the velocity of H2O, and you get this right here. So in this case, you're just looking for what factor H2O is faster than CO2. So just make the velocity of CO2 1. Just make it 1, just a plain factor of 1, because you're trying to see what you're really trying to solve for is what factor this is faster than that. So really your answer is this, the square root of 44 over 18. That's going to be your answer. So just make this 1, right? So if velocity of CO2 is 1 micrometer per second. It's not, I just said that, but if it's 1, then this is that number times that, so it's that much faster, right? So really your answer is what's under the radical. So maybe it's confusing because it's like there's two variables here still. Just make the heavier gas A instead of B. And so in that case, since H2O is lighter, it's gonna go up there where A is. And but yeah, let me know if you guys have any other questions or anything. I was having some more technical difficulties with Canvas today where I don't know why, but it wasn't immediately downloading the assignments you guys bring me on the side. So I think I kind of figured out how to work around it. I'm just downloading it the longer way, but I'm starting to figure out how to work around it now. So I don't think it should be an issue. Yes, let me know if you guys have any questions. Let's see if. Okay, cool. But yeah, so we'll have a quiz on Friday instead of tomorrow. It's just going to be on Charles' law, Guy-Lussac's law, Boyle's law, and the ideal gas law. It's just 4 problems, just 1 of each. So pretty quick. Tomorrow we're going to look at a little gizmo activity. And since those sometimes take a bit longer, I'm just not gonna give anything Thursday. So Thursday's like just a free day or just a day to keep working on the gizmo activity for tomorrow. As far as like due dates are, I'm gonna be really lenient with due dates just because of us getting used to this. You might have noticed on all these assignments, the due dates are always like at least a week later. Should the particle with the smaller molar mass be in the denominator always? Smaller molar mass. Well, yeah, that's just kind of like how the pattern works out because you know the lighter gas compound or element, whatever it is, particle, the lighter gas particle is going to be on the numerator up here for velocity. So the molar mass is going to have to be down there, right? So yeah, if you're not going to usually be given numbers for this, they might just give you CO2 versus H2O, just two formulas like that, and you have to look up the molar mass and then put them in here. So in that case, yeah, the smaller molar mass will go down here, and the velocity for that gas should be on the top over here. So just solve by multiplying both sides by what's in the denominator here. So multiply both sides by the velocity of CO2. And like I said, you're really just solving for whatever is under this radical. So what's the second law you said? Programs. Okay, I was double checking. Yeah. So for tomorrow's quiz, it's just gonna be Charles' law, Guy-Lussac's law, Boyle's law, and the ideal gas law. So yeah, Charles' law's volume and temperature being directly proportional. So you can think about it like Jiffy Pop. I don't know if you guys ever heard of Jiffy Pop. It's hard to find in stores nowadays. I used to sometimes get it when I was a kid. It's kind of expensive. It's popcorn, but instead of putting it in the microwave, it's like in an aluminum pan that you put over the stove. But I mean, normal microwavable popcorn does the same thing. You're increasing the temperature, right? While it's in there, it's getting hotter, and as the temperature goes up, the volume also goes up and inflates. Right, so that's Charles' law. You could also think of a hot air balloon for Charles' law, right? Because with the hot air balloon, you have to first light the torch, right? I've never been in one, but we know how it works. You light the torch, and that causes the gas to start to expand, right? The temperature goes up, so the volume goes up. Guy-Lussac's law is also directly proportional, but it's temperature and pressure. And sometimes examples for Charles' law could also be explained with Guy-Lussac's law because if the volume is going up, I'm sorry, if the temperature is going up, it's going to affect the pressure as well, directly proportionally. So good examples could just be tire pressure during the winter, for example. During the winter, the temperature drops. So that means the pressure is also going to be pretty small inside the tires because since the temperature is going down, they're moving much slower. So they're going to get a little more condensed close together. So they're not making as many collisions with the walls of the tire. So the pressure is going to be weaker. Guy-Lussac's law could also be things like firing a gun, right? When you pull the trigger of the gun, it causes the gunpowder to vaporize, become a gas, and that temperature skyrockets really, really high. And so since the temperature just has a huge jump, those particles are moving super duper fast, like compared to how they were moving before. So that pressure literally pushes the bullet out, right? So if the temperature goes up, that's kinetic energy, right? Temperature's kinetic energy. So they're moving faster. So they're going to be making more collisions. And again, the collisions is the pressure. Pressure is force per area. So the collision is the force that it's making with the surface area of its surroundings. Um, and then Boyle's law is inversely proportional. So on the quiz, you said that when particles collide, it increases or decreases velocity. Oh yeah, well that's just straight from the notes. So when it comes to it's an assumption. We're trying to idealize. The kinetic molecular theory is also just based on ideal gases too. So we assume that the collisions are completely elastic. What that means is there's no change in velocity. They collide and they go back at the exact same velocity. They don't slow down. They don't speed up. It's the same velocity before and after. So it's an elastic collision. Right. But then, yeah, Boyle's law is a pretty good one. Boyle's law is inversely proportional. So if pressure goes up, volume goes down. Right. So you could think about that like ears popping on a road trip. If you're on a road trip going to higher and higher altitudes, like in your car or even just flying in a plane, for example, um, you have a pressure drop because if you're going to higher altitudes, there's literally just less gas above your head, right? Because you're higher up, some gas is now below you. So the pressure is going down on the gas within your body, within your ears. So since the pressure goes down, Boyle's law says the volume of that gas is going to expand. So your ears pop because the gas is like pushing its way out of the ear canals a bit. Kind of like the idea of the bends too. If you scuba dive and you're deep, deep underneath the water, you have a lot of pressure on you under the water. There's like a lot of water putting its pressure and force on your body, so the gas is a little bit more condensed, right? The pressure goes up, the volume goes down. But then if you suddenly rise to the surface super quickly and like kick your feet off the ground, just go really quickly to the surface of the water, the pressure is dropping really quickly. So the volume of the gas is going to go up. So if the bends, it's a very dangerous thing where the gas within your blood, within your lungs expands too quickly and it can be super dangerous. But yeah, those are the three main laws we're going to look at. Ideal gas law is going to be on there too, but it's just putting them all together. Um, yeah, PV equals nRT. There's another gas law called Avogadro's law that we don't really focus on. It's also directly proportional. It's probably the simplest one. It just says if the moles of gas goes up, the volume does too. So that one's probably the most self-explanatory. Like if you're blowing up a balloon, you're blowing it up with gas, so the number of moles of gas is going up. So the volume's going to have to get up, right? But yeah, so it's going to be a pretty quick quiz. And it'll be on Friday now. So I changed it to Friday. It'll just be 4 questions. Yeah, so tomorrow we'll just have like a little gizmo activity, kind of like usual. You only have to do like 3 pages of it. I think it's 7 pages, but you only have to do three. If you want extra credit, you can try to do the other ones too if you'd like. But then I won't give anything Thursday just because I know it might take a while. So Thursday, you don't really have anything to do. And then next week, we'll start looking at the study guide for the whole unit, which isn't just this gas law stuff. It's also what we started with, which was liquids and intermolecular forces. So that's looking at polarity, right? So if the liquid is polar, it's either dipole dipole or hydrogen bonding. And if it's non-polar, it's just dispersion, as well as types of solids. And those parts of the notes on types of solids and intermolecular forces combined with gas laws, we're going to have all of those together as like our unit. So next week, towards the beginning of the week, I'll probably give out the study guide. And then probably by the end of next week, maybe on Friday, I'll have the test. I decided I'm probably not going to have them timed after all, just to make it simpler. Yeah, just to make it simpler for all of you guys, because we're kind of all getting used to doing things online and stuff. I'll just make the test without a time limit, really. And again, just because I know some people don't have internet access and some people don't have computer access, and I think the superintendent even kind of made it sound a little lenient in his letter. So like I don't mind if you guys want to retake these quizzes. You might have noticed if I graded your quiz on Canvas, I put the score down. Maybe it was like a 16 out of 20 or whatever the score was. I told you which ones you got wrong. I said you can retake this if you want to, so you can totally retake it. All right. Yeah. So let me know if you have any other questions or anything, or if you want to look at any other examples at all. But we're pretty much done with the unit now as far as notes are concerned. It ended with that gas stoichiometry stuff last week. Yeah, depending on how many questions we have or how many people end up showing up, I'll probably do this for like maybe 30 minutes or so. So about another 10 minutes, I guess, or another 12 minutes. He's a sleepy kitty. You just came here to take a nap. I'm actually allergic to him, but my body's gotten used to it, so it only affects me on cleaning days. Yeah, I hope you guys are doing well, and hopefully your other teachers haven't given too much work. I'm trying to do my best to make sure I don't give too much work. Um, I'm trying to at least be lenient with when I'm allowing them to be submitted. As far as lateness is concerned, I'm pretty lenient about that. But I feel like, I mean, compared to being in the classroom, it's definitely a lot less work. I feel like in the classroom, if I gave a worksheet, it'd be more than 4 questions. It'd probably be at least, I don't know, 10 or so. Yeah, so let me know if you have any questions or anything, or if you guys want to see any other examples. Yeah, hopefully you guys are staying indoors and stuff. They don't really even want us to like visit families and loved ones just to kind of make it as safe as possible. I've just been trying to look at some books and do some reading. Maybe you guys are using the time for some reading too, or some TV or anything. Yeah, so the test that we'll have next week is just this gas law stuff, and the note packet from before this, which was on liquids and solids, so intermolecular forces and the types of solids. That's like the main stuff we were practicing that we had a quiz on. We took that quiz like just right before I think we ended up leaving. It was sometime recently. So yeah, it's just gonna be like types of solids, intermolecular forces. There might be one question. Well, we'll see. It's all online now, so we'll see. There might be one question. Maybe it'll be a bonus question where you have to go through all the steps to figure out the Lewis structure, and then from there figure out the Vesper shape, and then figure out the polarity, and then the intermolecular force. But if I do that, it might be a bonus question just because I know it's online, so it might be kind of hard to I don't know show the Lewis structure really. Um, but yeah, I mean, other than that, there's definitely like some definitions and stuff to be aware of. Um, and then with the gases is definitely the bulk of this unit. So gas laws, as well as some of the conversion factors between temperature, Celsius and Kelvin, as well as atmospheres, kilopascals, and millimeters of mercury for pressure. So yeah, it's just gonna be that stuff. So this unit's really just about like phases of matter, basically. And then, yeah, next we're gonna be going to thermochemistry. I started working on the notes today. Um, so yeah, I mean, difficulty wise, I'd say it's about equal to what we're doing now. It's just like some algebraic stuff, so like solving for x. Um, there's no stoichiometry, so you guys will be happy about that. I don't think we're gonna see stoichiometry again. Um, but towards the end of that unit, there is a tricky concept called Hess's law, but that'll be like later on. Who knows? You might even be close to coming back to school by that point. Or maybe not. That might be towards the end of April. It looks like we're not going to come back until May 5th. So, yes, we have thermal chemistry unit. After that, we're going to have to look at a little bit of solutions and acids and bases, which won't be as long of a unit. It's probably a little bit quicker. And then we have like just one more unit after that on reaction rates and equilibrium. I like to try to talk about a little bit of organic chemistry stuff at the end of the year too, but I don't know if we're gonna have time for that. I feel like I've been trying to focus on like some of the concepts a little bit more in depth and just take my time a little bit more this year. So I feel like the last time I taught chemistry at my old school a couple years ago, I feel like it was a lot more fast paced. I was kind of just like going to each unit a lot more quicker, but I'm trying to take our time a little bit more now. So we might not be able to see organic chemistry, but even then, it's not much of a drawback. I think that was only an extra 3 days or something. So, because we didn't spend a lot of time on OChem, it was like just a couple of practice things and just a short little quiz. And it's not even necessary in the standards. It's just something that if you're interested in taking in college, for example, you'd end up seeing it. Because I don't even think like AP classes, AP Chem, they might lightly touch on OChem, but if they do teach OChem, it's probably about the same that I did, just like a couple days. So yeah, we just have a few more units, like three more units. So hopefully we should be pretty much on track. Might just be a couple days slow. Oh, good question. Velocity and speed have the exact same units. Meters per second is like the most standard unit based on metric scale. Velocity, however, is a vector, right? So speed is a scalar quantity. It doesn't depend on direction. Velocity depends on direction. So speed, for example, what's a good way to put it? Speed is always positive. Velocity could be negative. It depends on where you define your origin. So that kind of gets more into physics. So yeah, velocity and speed for the sake of this class, you can kind of just think of them as the same thing. If you take physics, though, they're definitely different. I mean, numerically, they're the same. It's gonna be the same number. Um, it's just with velocity, it implies direction. So velocity, it depends on which direction you're going. So there's a positive direction, like think of like the x-axis, like the Cartesian coordinate. So a positive x, positive y. So if you're going this way in the positive direction, it's a positive velocity, like 5 meters per second. But if you have 5 meters per second going the other way, it's just negative 5 meters per second. So velocity is just a vector. Hmm. Are you are you looking at the right quiz? It's the one that says kinetic molecular theory, because one of them isn't open yet. The gas law, ideal gas law one's not open yet. But the kinetic molecular theory one, that one is available. That one should be ready to look at. Yeah, so for the sake of chemistry, you can just think of speed and velocity as the same thing. Their magnitude is the same, right? So velocity is just based on direction. Yeah, speaking of which, I highly recommend physics. Take physics next. It's even cooler than chemistry. Chemistry is great, but physics is even more interesting, I'd say. And it's more consistent too. You might have noticed in chemistry, I feel like the math kind of varies a lot. It's like algebra one unit, fractions the other unit, drawing Lewis structures with, addition, subtraction, that it's like kind of math always varies a lot. Physics is a lot more consistent. So the kinetic molecular theory one. Okay. Who are you again? I don't know your actual names. I just want to make sure I can maybe at least send it to you or something if you're having trouble. That's strange. Maybe Canvas has just been having issues. I mean, they've been acting. It's been acting kind of slow for me today, so maybe it's just a Canvas issue. Yeah, just let me know who you are and I can send it to you. Oh, hey Josh. Um, yeah, I could try sending it to you. Um, I'll just send it to your email though, your student email. So as long as if you're able to check that, you should be good. Um, um, Josh Fisher. I'm going to send. Yo, what's going on here? My computer's just acting weird. Let's try that again. So I'm gonna try to just send it to you. Maybe it's an issue with your account then. I'm not sure. Yeah, I haven't gotten anything. Oh, I just got your messages. Well, I haven't checked it in a few minutes. It's strange. I'm not sure. Well, I'll just try to send it to you. Quiz on kinetic molecular theory, Dalton's law. What's that one? All right. Well, I just sent it to you. Yeah, I'd maybe see if you can, talk to someone from the district about that. They have like a help desk on the district website, and I think you can even just like type in your issue and they'll get back to you. Because if it's something wrong with your account, that's going to affect all your other classes too. So that could be serious. Don't work on live stream either. Oh, you know what? I'm not sure. Maybe that's just because I'm using this live stream with my own personal account. This isn't my school account. This is just my personal account. So maybe that could be why. Yeah. So I don't know if you guys have any other questions or anything. Yeah. If you guys have any other questions, if you want to look at any other examples, let me know. Yeah. Just maybe see if you can talk to the help desk. Let me see if I can find you that. Here. Got two computers right now. Claremont, USD. Hmm. Yeah, I'll see if I could. To be honest, I'm not sure. Let me see. Oh yeah, Tor is just an abbreviation of the guy's last named last name. It's plural. His name was Torricelli. So he was an Italian physicist. So yeah, it's short for Torricelli. Let me see if I can find you Josh, the guy's information that could help you. Um, who is it? So I could find staff. Yes, staff. No departments. Okay. Technical support. Yeah, I'll see if I could. Maybe one of these guys is good with Canvas. I don't know. If not, I'll just. Or you're having an issue with your account though, so it's a little bit different. Yeah, I'll just send you a couple of these things, Josh. All right, Josh. I'm sending you two email addresses. They're both people that specialize in desktop support for Claremont High School, so I'm gonna send them to you as a follow up to the other email I just sent you. So they might be able to help you out with your account if you're having issues with it. Oh yeah, they're all on Canvas. Those notes are on Canvas too. So yeah, if you go to the notes, there's one file under notes that says gas law notes, con videos, and demonstration videos. That's the one that has Boyles, Guy Lussacs, Charles, all those ones. Yeah, so it kind of goes in order. Yeah, that's the third one. And then after that, we have combined gas law, then we have ideal gas law, then gas stoichiometry. So yeah, it's under gas law notes, labs, and demonstrations. Yeah, it's on your school email. Excuse me. Oh, cool. Yeah, so tomorrow, like a little gizmo activity kind of assignment. Like I said, you only have to do like a third of it. It's like 7 pages, so well, I guess it's more than a third of it. But, a little less than half of it. You only have to do 3 out of 7 pages. If you wanna do more, you can do more. And I won't give anything Thursday just so you can have some more time to work on that, especially if you need help with, like, your password and stuff, just let me know. And then Friday, we'll have our quiz on the gas laws. Um, and then, yeah, Monday, we'll probably just start looking at, like, a study guide, maybe just get a little bit more practice during the week, just having some time. I probably won't get as much work next week other than the study guide, just to give you guys some time if you have any questions and just to, like, practice and just soak in the information. And next week, too, around the time I give the study guide, I'll probably also post some of the solutions to the homework assignments. I didn't do the solutions for every single problem, but just like some of the odd problems, the odd numbers. So I'll post that next week too. So yeah, Monday or Tuesday we'll probably look at the study guide next week, and then next Friday, April 3rd, we'll probably look at the test. And then the week after that is technically still our spring break. I know we're, not at school physically anyways, but the week after that's technically our spring break. Oh, hey. Hey, Isaac. So the week after that, we're not really going to be doing anything, right? That's April 6th to 11th, that week right there. So that'll be spring break. So next week, we'll, have the study guide, look at the test at the end of the week. But I won't give out too much stuff next week just to make sure you guys have some time to ask some questions. But I'll post some of the solutions. Like I'll probably post like the odd solutions to the study guide too. Hey, how's it going, Mohammed? Yeah, so if you guys have any other questions, I'll probably stay on here for a little bit longer. I think I was able to figure out how to work around that error that Canvas was giving me, so I should be able to grade some of these assignments now. I'll let you guys know if anything weird happens. I was trying to contact Canvas support before doing this, and there was like 56 callers ahead of me. Um, but I didn't want to delay the live stream, so I just got off the phone. But I think I'm able to work around it now. Yeah, I hope you guys are all safe and well with your families. Hopefully, the virus hasn't delayed or caused any issues for you guys. I know those of us who are Aries like myself, we gonna have a much more, I guess, chill indoors birthday this year, which is cool. My favorite idea of a birthday is probably more chill, just sitting inside watching some TV. The only thing I'm kind of bummed about is I had tickets for a concert in May, and it's postponed. So I don't know if I'm gonna get refunded or not, but we'll see. Yeah, I hope you guys are doing well. I'm actually kind of enjoying it. Yeah, it's nice just to everything just really low key and easygoing. It's a little bit frustrating not being able to leave. I haven't really left the house other than just like picking up delivery every now and then. Um, but yeah, I'm gonna try to go back to the grocery store maybe on Friday and just hopefully see what I can find. Um, yeah, it's been okay. Just trying to do like indoor stuff, indoor workouts. Yeah, it's been nice. I've been trying to catch up on some reading. 14.3. Yeah, so for gas stoichiometry, that's typically the only cases you're gonna see is when you're given and what you're trying to find is all just gases. So the reactants and products both being gases. 14.3. Let me just double check which one that probably is. Let me see. One second. I'm gonna go over here real quick. I don't know if you can see me still, but I'm on a different page now. Let's see. 14.3 gas laws. So you said the last example on the bottom. No, I got the rainbow wheel of death, so I gotta wait. 14.3, last example. Okay, so the ideal gas law, all right. And the last example, so what volume of CO2 forms when 500? Okay. Um, so Bushra, just to double check, you're talking about the one that says what volume of carbon dioxide forms when 525 milligrams of calcium carbonate, completely reactive hydrochloric acid, assuming the carbon dioxide is formed at a pressure of 101 kilopascals and a temperature of 25 degrees Celsius. Um, no, not that one. I think it's the last example under 14-3. Let me double check. Let me see. Oh, my computer's acting all weird now. Oh, come on. Okay, finally, my computer was acting weird. So you're looking at the example under gas stoichiometry. It says solid calcium carbonate decomposes to form carbon dioxide gas and solid calcium oxide. Oh, the first one. Oh. So you're looking at the one that says calculate the pressure in kilopascals of 1.65 grams of helium gas at 16 degrees Celsius. Is that the one, Bruce? Yeah, I started grading the quiz. I mean, you still have plenty of time to take it, and you guys can retake it too. Yeah, I started grading it already. All right, yeah, for that one. So with that one, we're definitely using the ideal gas law, right? Because this is an example for the ideal gas law. Plus, another way you can tell it's gonna be the ideal gas law is with Charles' law, you have volume and temperature, right? Gay-Lussac, it's pressure and temperature. Sorry, and with Boyle's law, it's pressure and volume. So in this have to be the ideal gas law. I don't know off the top of my head, but you can check Student Connect, Isaac. It's all on there. Just open up the app. But yeah, so you have the mass is 1.65 grams of helium. So we can't use grams though in the ideal gas law equation. We have to use moles. So first, you have to convert 1.65 grams of helium to moles of helium, right? So to do that, you just divide it by the molar mass. The molar mass of helium is 4. So it's just 1.65 divided by 4. And you get 0.412 moles. Here, let me just show you guys. So, right, so you're trying to find, they wanted you to find pressure here. So just divide both sides by P. I'll show you what I'm doing in just a second. So P is nRT over, no, V is nRT over P. All right, so are you trying to get pressure? You have something like this. I'm sorry, trying to get volume. Wait, no, you are trying to get pressure. Sorry, guys, I'm all over the place. My bad. Let me fix this. Sorry, guys. Right, you're trying to find pressure. So I'm dividing both sides by V. Sorry, guys. So that cancels. All right, so this should look better. Right, so you're trying to look for the pressure. All right, so T is the temperature, which is 16 degrees Celsius, but we have to convert that to Kelvin. So 16 plus 273. I'm just do it one step at a time. That's the temperature, right? 16 plus 273. Now, for the R constant, again, R constants, there's two that we're typically going to look at. And in this case, we're looking for a pressure in kilopascals. So we have to use this R constant. Let me show you guys. 8.315 kilopascals, liters over moles, Kelvin. All right, so you can use that R constant, 8.315, because it has the kilopascal unit there. That kPa is kilopascals. That K down there is Kelvin. The other one that you might see sometimes is 0.08215, I think. And that one, the only difference is instead of kilopascals up here, it's atmospheres. But again, this whole thing is a unit. People sometimes get mixed up. They think you have to plug something into that. Those are just the units. So that's your R. Your temperature is 16 degrees Celsius, but you have to add 273 to it. Now, N is the moles, but they gave us mass. So we have to convert. They gave us 1.65 grams. Yeah, 1.65 grams of helium. So 1.65 grams, you have to divide that by 4 to get to moles. So yeah, so you're just doing 1.65 grams divided by 4. So your grams cancel and you end up with moles. So that's how you can get your moles. And you just divide it by the volume. Right. So the volume is 3.25. You're talking about, do you put any numbers in the fraction next to 0.821? Where's 0.821? Is that the other? That's the other gas constant. Oh, yeah, that's the other gas constant. It's 0.0821. So yeah, R is gonna either be, yeah, it's a common thing. People sometimes get mixed up with. It's 0.0821 atmospheres, liters, moles, Kelvin, or it could be the one I'm just using this example, 8.315 kilopascals, liters over moles, Kelvin. So again, those are the two R constants at the bottom there, right? And they're just constants. And these are just the units. Their units are just crazy. So instead of just being like grams or moles or Kelvin, their units are a combination of four other units, right? It's atmosphere liters over atmosphere liters over mole Kelvin for this value. For this one, it's kilopascals liters over mole Kelvin. So all the units are the same here, except this one is for pressures that have kilopascals. This one is for pressures that have atmospheres, right? But there's nothing to plug into these. These are just the units, right? The reason why its units are so crazy is because if you take the ideal gas law and try to, solve it for R, that's what you're gonna get. Here, let me show you. This whiteboard is really flimsy, so it's gonna get bent. But here, PV equals nRT. If I want to get R by itself, divide both sides by NT, and you get that R is pressure times volume over moles times temperature, right? So using the ideal gas law, PV equals nRT, you get R by itself. I'm just showing you where the units come from. This isn't like a problem you'd have to do at any point. But when you're getting R by itself, it's pressure times volume over moles times Kelvin. That's why the units are always either atmospheres times liters, which is pressure times volume, or kilopascals times liters, but it's always divided by moles times Kelvin, because it's just based on these four things. So yeah, the chemist should have probably originally just made it an easier unit, maybe like, I don't know, a letter, but its unit is literally 4 units combined, like miles per hour, right? 2 units combined. But R just has 4 units combined. So those are just units. Um, Let me double check if I missed any other questions. Yeah, they might have to make up that work when they come back, which could be stressful. And we're still trying to figure out what we're gonna do about that. To be honest, there's a lot of improvisation type stuff. Truth be told, I don't know which to use. Yeah, exactly. So it depends on if you're using atmospheres or kilopascals. So if your pressure is given to you, like it's one of your givens, just look at its unit. If it's kilopascals, you use the 8.315. If it's atmospheres, use 0.0821. Or if you're looking for pressure, you could really use either unless it specifies what's the pressure in this unit or what's the pressure in that unit. But yeah, that's only if it specifies. When I find out stuff. Oh no, because they all cancel out. So like, if you're looking for volume, for example, here I'm just gonna like. That's the reason why its units are so crazy, so everything else can kind of cancel. So if I'm looking for volume, volume is moles times R times T over pressure. So I'm just gonna put like some random numbers here, but I'll show you just how everything cancels out. So I'm gonna do 0.0821 atmospheres, liters, moles, Kelvin. Temperature, I'm just gonna say is like 500. I'm just making these numbers up right now just to show you how the units cancel. And let's have a lot of pressure. Let's have 5 atmospheres, right? So if I'm looking for volume, if I'm looking for volume, this thing up here, I just made up these numbers, but moles cancels with those moles down there, right? So those moles are going to cancel. Kelvin cancels with those kelvins down there. And then atmospheres cancels with those atmospheres down there, right? So the atmospheres cancel with that atmospheres, those moles cancel with those moles, that Kelvin cancels with that Kelvin. So all you have left over is liters, which is perfect because you're looking for volume. So that's the reason why its units are crazy, just so all these other ones can cancel out. Yeah, so it all cancels. Can we get 48 more subs? I am confused by the question. Let me know if you guys have any other questions at all. But yeah, so on Fridays, again, it's not tomorrow. The quiz will be Friday, but it's just going to be like 4 questions: one Charles, one Guy Lussac, one Boyle's, and one ideal gas law. So with the whole entire combined gas law, it's basically two. It's like you took an ideal gas law from one gas, an ideal gas law from another gas, but you said it's like you're saying they have the exact same number of moles, basically. So we know R is a constant. So you know R is PV over NT, right? So if you have two different gases mixed together, and it's the same number of moles, right? So P1, V1, T1, and this is P2, V2, and T2, right? So for gas 1 and gas 2, something like this. So for gas 1 and gas 2, so R is a constant, so R is just PV over NT using the ideal gas law, right? Probably would have been better to do ideal gas law before the combined gas law. I'll probably do that in the future next time. But the assumption here for the combined gas laws, you're saying they have the same number of moles. So whether it's like, neon gas and carbon dioxide, whatever the two gases are, even if they have different pressure, volume, different temperature, those things can be variables, right? They're different, but you're assuming they have the same number of particles, the same exact number of moles, like 1 mole of helium, 1 mole of hydrogen, or so on and so forth. So that way the ends cancel out on both sides, and then you get the combined gas law from that. Okay, yeah, so let's go back to that problem. So that problem, here, I'll look at that example again. So let's see what we got. We're looking for the pressure in some sort of, what's the unit, kilopascals? So I'm still looking at the first problem. The mass, here, I'm just gonna convert it right away. The moles is gonna be that mass, 1.65 grams, divided by the molar mass, which is 4 grams per mole. So whatever that is, I'll do it on my calculator later. The temperature and the volume is 3.25 liters. All right, so let's see. The moles is 1.65 divided by 4, so 0.413 moles. 0.413 moles. And then 16 plus 273 is 289. Yeah, 289 Kelvin. All right, so you're looking for pressure here. So I'm just going to solve for pressure right away. So that's nRT over V. All right, so all right, going back to this thing over here. This was that first example you asked about, Bushra. We don't know the pressure we're trying to solve for that, but we know they want it in kilopascals. You could really we're only doing a specific R value here because they asked for it in kilopascals. If they don't specify the unit of pressure, but you're solving for pressure, you could use either of the R values. For the moles, it's that mass divided by the molar mass. This is helium, right? So we divide it by the molar mass of helium, which is 4 grams per mole, right? So it's from the periodic table. So those are our moles. Temperatures in Kelvin, so just add 273. And volumes down there. So I know I'm going to have to use the one that has kilopascals in it. So let me show you. So 0.413 moles. I might run out of room. 8.315. See if I can cram this in here. Kilopascals. Here, I'm just going to scoot it over a little bit. Thanks for your patience. Let me scoot it over here a little bit. P is nRT over V. N is 0.413 moles. R was that 8.315 kilopascal liters over mole Kelvin. And the temperature is 289 Kelvin. And the volume is 3.25 liters. All right, so the moles are going to cancel, liters cancel, and Kelvin cancel. All right, so this is that example you asked about, Bushra, the first example. So these are just all my givens. Right, so I'm looking for pressure. So I just divided V on both sides. I just skipped that step and just put it down here automatically. So my moles is 0.413 moles, right? We divided the mass by the molar mass of helium. And the R I chose was 8.315, right? Because that's the one that has kilopascals in it. And this problem just asked for kilopascals. So since that's what they asked for, we have to use this one. That way our unit can end up with kilopascals. And the temperature, right, we had to add 273, so it's 289. Excuse me. And the volume's down here, 3.25 liters. All right, so the final answer is just in the notes. So it's, what was it again? It was 305 kilopascals. Yeah, everything looks good. Cool. Yeah, so you should get like 305. No. Almost left the live stream. You should get 305 kilopascals. So yeah, I had to use this R value because it asked for kilopascals. If it asked for atmospheres, then I would use 0.0821. 21? Yeah, it's a 21. Exactly. Yeah, that's why the units for R are so crazy. That way the moles can cancel with R, the liters can cancel with R's units, and the Kelvin can cancel with R's units. So R has all those units there. So if I was looking for volume instead, the V and the P would switch. There'd be a P down here, and then the one unit left over would be liters. So whatever you're looking for, that's going to be the unit left over in R's unit. Yeah, so R's unit is going to have things cancel out, and whatever's left over is the unit of what you're trying to look for, basically. Yeah, so let me know if you guys have any questions. I'll probably stay on here for a few more minutes, unless anyone has any like questions about any problems or anything. Oh yeah, no problem. Stay safe too. Yeah, let me know if you guys have any questions about the homework or anything. Hmm. I don't think I'm currently watching anything on Netflix right now, but hmm. I mean, if you like comedies, Arrested Development's pretty funny. That's a good one. It's kind of fast paced. It's called Arrested Development. That one's pretty funny. I've been rewatching The Office a little bit. I mean, I guess what I've been watching. I'm trying to catch up on all these Clone War episodes on Disney Plus, and Clone Wars is pretty fun, but sometimes it's also kind of dry. I'll admit. So I watch it every now and then, but I'm also rewatching some other shows. Um, I was watching a lot. I've been watching a lot of Fresh Off the Boat on Hulu, which is pretty funny. Fresh Off the Boat's been funny. That mom's insane. Um, yeah, it's not bad. It's just sometimes it's kind of slow. Clone Wars. It's like some episodes are really good, and some episodes I'm like, oh, okay. um, what else would be good? Hmm. I know Peaky Blinders is supposed to be really good. I've only seen the first couple episodes. Um, yeah, with Netflix, I'm not sure. It's been a while since I've seen shows on that streaming service. Mm, a really good show, which I think is on Amazon Prime. It's kind of dark, but it's very exciting. It's a good show. It's called Mr. Robot. That one gets kind of intense. It's kind of like it's about conspiracy theorists and stuff like that, but and just like hackers and things. But it's a really good show. That one I highly recommend. But yeah, I've just been kind of rewatching other things. I just started getting into King of the Hill on Hulu, and I'm rewatching Workaholics on Hulu again. So it's kind of I like to watch comedies. Yeah, so if you guys have any other questions, I might probably sign off in just a couple minutes then. Yeah, Arrested Development's pretty funny. That one's on Netflix. It's like a comedy show. It's pretty good. First 3 seasons are good. After the 3rd season, it kind of is not as good. I think I stopped watching. I didn't catch up with it, but the first 3 seasons are really good. It has Michael Cera when he's like really young. It's like a young Michael Cera. Yeah, Parks and Recreation is really funny. I should rewatch that one again. That one's funny. I've probably rewatched The Office like 5 times. There's 2 Frozens. Hey, Kitsy. Meow. Alright, well, I'll probably take off then, guys. I'll try to do another one of these maybe later on this week, either Thursday or Friday, maybe Thursday, just in case you guys have any questions before the quiz Friday. So yeah, we'll do like a little gizmo activity tomorrow. I won't assign anything Thursday just to give you guys some more time to keep working on the gizmo activity. And then Friday we'll have our little quiz. Monday and Tuesday we'll probably work on the study guide. And other than that, we won't do too much next week, just to kind of give us some time to review, and you guys can ask me some more questions if you need any help with anything. I'll post some solutions next week too, and we'll probably have the tests next Friday, April 3rd. And then after that, that next week is spring break, and then after spring break, we'll probably start the next section. But yeah, probably Thursday. I'll probably do another live stream Thursday just because I know I'm not going to assign anything that day anyways. And then Friday, we'll have our quiz. So that way, the day before, we can go over any questions if you guys have any. I'll probably do it around the same time, like 1 or 1:30 ish. All right. Well, I hope you guys all stay safe and have a nice rest of your day. I'll probably take off right now, but stay safe, guys. I'll see you Thursday if you want to join the live stream. But yeah, have a nice day, everyone. See you later.